I was asking of any recap yesterday, and to Afrik, please be very apt in recording the names. Ebenezer is on the line. I believe that today is the last day, so whoever hasn't spoken, make it a point to speak. Ebenezer, go ahead.
Has to speak today. You have to hear from everybody today.
So yesterday we got to know that sigma is a Greek word that denotes standard deviation. That is the deviation from the mean. And then we also learned that when we talk about the 6Sigma, we are referring to the degree of variation, performance level in the variation, the statistical measurement of process capacity. It also talks about the goal, then the benchmark of comparison, as well as strategies for change. So those are the basic things that I think I learned yesterday. And then technically, we're looking at the definition of sigma. Technically, we said that is the 3.4% defect from a million opportunities. And then from the business point of view, we're looking at the strategies for significant improvement in customer satisfaction. So that is what I learned yesterday. Thank you.
You do all. Yeah, who else?
Doc.
Yes.
Good morning again. From my end, I can see that the first thing that I noted was from the question asked. You advised that any system implementer will tell you that when you are dealing with a system, there's always a non-value item or a human element. That was key. You also talked about the CPK, which is used to measure sigma level, and the meaning was process capability index. I tried searching through the net to see if I could familiarize myself with the formula, and I saw something that was very useful. That's the upper specification limit. There's a formula to that effect, which has something to do with the USL and then the LSL, which is the lower specification limit. The other thing is that we could use Sigma as a 6-year strategy and measure our performance as we progress. It was significant to note also that if in Sigma, there are belts and it starts from the white and it progresses from there. The mindset of Sigma was also learned, and I remember that you had said that for you, your mindset of Sigma, Lean, and then business simulation buttresses the philosophy of Cosby, and this is something you share. Looking at the strategy that BOA, as the Bank of America, used, it was significant to know that you can't implement Sigma without clearly defining your goals, without clearly preparing the team and moving on from there. If you look at Cosby, who thinks that the responsibility in terms of quality, he thinks that the responsibility lies mainly also with senior management. It was clear. We also recognize that the training was not only for the senior management, but it ran through all of them. But the significant portion was the senior management, because quality starts with them and quality involves everyone. I took note of the defect per million opportunity level thing you mentioned. And the last thing was that to implement lean, I think a question was asked, and you asked that to implement lean, we must first start with the conceptualization of it and lean, and consider lean as a soft skill. And even if you are implementing quality management, total quality management, you should also think of that as a soft skill before you can implement that. So that was a useful lesson for me. Thank you.
Please, who just spoke? Is that Robert, engineer?
Yes, Artofik, please, Robert.
Okay. Yeah.
So please go ahead. Who is Charlie? You do, or I like the elaborate overview. Keep it up. Who else?
My doc. Doc, in this instance, sometimes he speaks almost everyone's mind too. So that we don't have enough time.
I'm not being in my inside. Make you to talk the one way you talk. I beg you.
Cafe Julo,
Take what you said and plagiarize. Hey. Anyway, hi, Doc. Yeah, so so for me it was finally understanding that 6Sigma is actually a goal, and there are various companies who are at various levels of implementation. So far, well, not many people are at that 3. I don't even know one that is at 3.4 defects per million. Also, one of the last things we noted was there's a difference between lean and then 6Sigma. Lean is actually process-based, while 6Sigma is actually output-based. Yes, that's what I learned yesterday. This is Johnny.
Morning, Doc. Morning, class. I'm Ebenezer. I think yesterday what I learned was the definition of Sigma, the 6Sigma, as a breakthrough strategy that gives a significant breakthrough strategy that gives significant improvement to the customer satisfaction, and then a value to stakeholders in reducing defect in all aspects of a business. And then we also went through DMAIC, and then we look at what make 6Sigma outstanding from other strategies, being outstanding in that it considers leadership through to the least worker, that is giving training to all part of all stakes in the business. I think in summary, this is what I may say.
Hello, Doc. This is Gideon Obing. I also learned from yesterday that 6Sigma is not just it's not a standard or a certification or another metric like percentage. It's a real measure of quality, striving near perfection. And you made us know that the sigma is a Greek letter representing the standard deviation of a set of populated data. So sigma is a measure of variation, and where the variation exists in almost every process. And then the variation needs to be measured so that actions or corrective actions can be taken to whilst we are trying to get to perfection. So those are what I also pick up yesterday. And you took us through DMAIC, which is a logical and a structural approach to problem solving and process improvement, which the DMAIC start with define, measure, you analyze, you improve, and then you control. All those you took us through. So those are the things I also pick up yesterday. Thank you.
All right, Charlie. You guys, they killed the thing. I didn't hear the voice of a lady. Then to Africa, Amma was the first person who joined. So I think that you should write her name for today too. I don't know whether it's a normal behavior of them, because my wife wakes up at 4 a.m. I think it's normal with those Amma. So I mean, can we
Yes,
have
Doc.
some
Okay.
of the ladies? Can we have some of the ladies?
So I would like to add this. Yesterday, you also explained that 6Sigma is a goal that companies need to work continuously to attain. It's something that you can just get when you decide that you want to implement that in your manufacture, like in your organization. So it's more like a destination. And then you need continuous improvement to be able to attain that goal. I think that's the main thing I also took away yesterday.
Deles, thank you so much. Can we have another lady? Eunice, are you there?
Yes, I'm here. Good morning.
So I have Eunice. Eunice has been another contributor here, to be very fair. Sandra is here, Sonia. Sandra, they are not here in voice before. Sonia is also, I think Sonia spoke once. Eunice, do you have anything to share?
Hey, Doc, I've spoken before.
What? Who?
Sandra here. I have spoken before.
Oh, I knew that when I say that you speak. So now go ahead.
Okay, so yesterday, what I picked from yesterday's lecture was the 6Sigma project methodology, where we talked about the DMAIC, define, measure, analyze, improve, and control. Those are the phases that any company goes through to attain the 6Sigma goal. And you also mentioned that you cannot improve anything you can't measure. And so based on that, after defining or identifying the project or the goals that you set for your team, you set up the criteria for measuring. And so based on that, you're able to identify the key requirements of the customers. And also you are able to analyze the data to establish a firm determinant for the performance. And then you improve on your designs and also control. That's the continuous improvement that is the final stage, and that you evaluate. So that's what I picked from yesterday.
Hello, Doc. Good morning. Good morning, class. This is Francis. Yes, Doc, as much as yesterday we established the fact that Sigma is a goal, you also emphasize that it's not a one-time achievement, it's a process. Therefore, the human value or factor can never be ignored, other than that there might be a lot of issues, so that you start with them, and then along the process, as you improve, you eliminate those that does not add value to the chain. So I learned that it's not a one-time goal. You start and then you improve gradually as you aim to achieve the main goal you've set. Thank you.
So the last person.
Hello, Doc.
Yeah.
Yeah, I also want to say something. We also established the fact that since 6 Sigma is a process improvement, it's not like when you are practicing, you won't have defects, but because it's a continuous process improvement, you'll be able to work on your processes and your products to reduce the effect. That's the end goal of getting only 3.4 defects per million production. So that's what I also took away yesterday.
There's one significant thing you said, the end goal. The end goal. That's very, very the end goal. All right. Thank you for always coming for lectures late. Earlier. It's a good. You are an engineer. You are an engineer, eh?
Yes.
Okay.
Look, I remember one last thing you spoke about yesterday. It was one of the things I pick up. I mean, the difference between lean and then 6 Sigma. And then you said lean is a process focus. It looks at the efficiencies, the effectiveness of the processes, whilst 6 Sigma is an output focus, and then it also looks at the effectiveness and efficiencies of the outputs. Thank you, Doc.
All right. And who was that? Gideon. Okay.
Yes, please.
Gideon.
Good morning.
Morning. Could you answer?
Yes, sir.
I was supposed to have returned your call yesterday, actually.
Yeah. You talked today after class.
Yeah.
Okay. Doc, I want to ask a question. The 6 Sigma, which philosophy will it fall under? Is it Cosby or Juan? Since the 6 Sigma is also a process thing, we have to.
I think that's a good question. I think the 6 Sigma, the DMAIC flow that we used, that answers this question for us. And I want to take you right there, because you asked you can see the screen.
Yes, Doc.
Okay, let me see. So what do you see?
Okay, I see Joanne. Okay, I see Joanne. And
then has this answered your question?
Yes, sir.
Okay. So
there's one question, because the 6 Sigma try to eliminate defaults, and even at the rate, according to yesterday, what you learned, that's about 3.4. And then the Cosby also believes that default is something that we shouldn't even entertain it, or something that he doesn't even believe in it. So if 6 Sigma is also working towards that aspect of it, you should also say Cosby also used the 6 Sigma as his philosophy. That's why I'm a bit. confused.
Okay, so you shouldn't be confused. The underlying principle of 6Sigma is Sheward's, and when I mention Sheward's, then Derman and Duran becomes some kind of somewhat, a little bit less important, because in fact his philosophy is what they built on. So these two guys, they were seeing Sheward as a mentor, right? But what makes this thing, they all have a certain goal to achieve. But remember, 6Sigma starts from Sigma 2. You have the patience to accommodate what the waste, improve Sigma 3, improve Sigma 4, in that order. And if you look at the variation of the waste at any point in time, Crosby doesn't have patience for that, right? So that's the difference. Okay, that is the difference between these two guys. They are saying that continuous improvement is a process. Okay, so let's go through and let's make sure we get to the destination. Let's allow people to make mistakes. They can correct it over the period. Crosby has a different view on that. And that is why he's saying that he doesn't accept statistically acceptable levels of what's defect. He doesn't. Okay, that's what he says. So that's and you remember in the presentation we said either Juan or Dermin believes in project by project, while Crosby says that he deals with process. He goes to the least process, make sure that everything is okay. But these guys are dealing project by project. So it means that they allowed waste to enter into the system, but over time, they are able to improve and then eliminate the waste. So these are the two differences between these guys. I don't know whether it makes sense.
Yes, Doc. I'm okay.
Do you get what I'm saying? The
Yes,
guy
sir.
doesn't entertain, waste. He says get it right at the first time. That is his principle. These guys are saying that you can continuously improve. So you shouldn't be confused about that. The fact that these guys are able to achieve 3.4, I'm not sure any company that we have reviewed has been able to achieve the 3.4 yet. Okay, and because it's a goal, they keep working at it. Others I hear have been able to achieve. I'm yet to see a case study like that, but that's the reality. Okay, so so what we're going to do today, I'll treat this topic and quickly take you also through the leadership. Is it the leadership? Yeah, leadership change. And then we have a break and you guys take some few minutes, and then Kwabna will come in to give his word, or I'll share some thoughts on the areas to look at. Then Kwabna will come in, Ampon will come in, and then that will be it. I need to send him there. So this what we are going to do is still on objective 3. Okay, or outcome 3, where it says that develop new products and processes into the organization. Okay, so let's look at design for 6Sigma versus DMAIC. Now, the only difference between these two is that design for 6Sigma is for a new product that or service that you are developing, and then the other one, which is DMAIC, is for an existing process. Is that clear? That's the only difference between the two. And we are saying that people confuse the two, but they are not the same. So a majority of time, when they are using DMAIC methodology, because they have existing processes that are wasting resources, okay, Hence, they have to use that. So hence the big savings you have heard about GE, Honeywell, and others over the past period has to do with DMAIC. All right, because they already have an existing process. But if you have new process and you want to start improve, you are setting up a new production center and you want to use some of these strategies, it's important that instead of going to do DMAIC, do DFSS. The reason is that you can build the system mistake proof from the scratch. Okay, you can do that and make sure that there's variations and then waste and non-value added activities are all reduced to the barest minimum. So said the remaining minority of 6 Sigma practitioners are using a design for 6 Sigma approach to design a new product for 6 Sigma quality. They are using that too. So those who are setting up, a new company, please take note of that. Okay, take note of that. I believe we have self-employed people here, do we? I think I had one when I was taking you guys your profile. Do we have any, there's one self-employed person. Oh, I know some of you do things, in addition to your work. That one, no two ways about that. Because if you don't do that, then you have a problem with the haircut. Yeah.
Doc, I'm also on my own.
Who said this on your own? You're on your own.
Yes, sir.
Oh, you are your own boss.
Sir, that's it.
Oh, okay. Yeah, we need to meet. I think that anyway, remind me to share some thoughts with you when we are done. So when people refer to 6 Sigma, they are in fact referring to DMAIC methodology, and the DMAIC stands for define, measure, analyze, improve, and then control. Now, the DMAIC methodology is used when you have an existing company that has a process and you want to use that as a breakthrough strategy to correct things. It is universally acceptable, and D stands for define, measure, analyze, improve, and control. Now, in most of the businesses, they look at this thing in phases, okay? And some companies use the define to as like what these guys did, Bank of America did. They use it to do some sort of measurement, okay? They define the goals of the organization, set up the project team and everything, and they collect the data at the stage of measurement, and then they do some analysis to understand it, and then put in improvement strategies, and then after that, do some sort of put in some control measures. So that's what they do, and we've done that extensively. So we know what DMAIC is. What we have not noticed or what we have not done is what the DFSS. So we know about this, and we say we know what Sigma is. It's a philosophy, it's a vision, it's a goal, it's a method. But I want to draw your attention to this. But why are we putting? Whilst I do that, let me pull this data. The question is, why are we? If standard deviation, let me ask this rhetoric question. If standard deviation talks about is the deviation from the mean, okay, why are we putting six of the deviation in the process? And we are naming it, we are saying that rather reduces the waste to the barest minimum, and it brings improvement. When standard deviation is deviation from the mean. You get my question? You get my point?
No, please.
Standard deviation means deviation from the mean. Do you agree with me on that?
Yes, please.
Yes,
so
doctor.
if it is so, and you say that when we put 6 of the standard deviation in a process, we will reduce variation up to a certain level. How is that possible? How is that possible? Oh, let's talk. How is that possible?
So this is what I'm thinking. So I'm thinking that since the mean is the average of, let's say, whatever result that we want, by choosing the standard deviation is deviating from the average. It's like we are trying to get a perfect result instead of an average one. So if we choose the 6 deviations from the mean, it may help us improve the process and we'll get an almost perfect result instead of an average one. So this is how I'm seeing it.
Please say what you said again.
I'm saying that since the mean is an average of like the product or the results, and standard deviation is deviating from the average, it's like by using those 6 sigmas, we are trying to move away from an average result and trying to get an almost perfect results.
But the point is that the deviation, the sigma means deviation from the mean. So if we take the mean as the requirement, okay, and standard deviation is deviating from the requirement, okay, then what it means is that we are moving, the deviation is rather moving from what? The mean. You understand the point I'm making?
Not entirely.
No, I'm saying that, let me use this to illustrate that. Can you see the screen?
Yes, please.
Yeah, I wanted to do this. This thing is very important because we never spoke about it. Now, this is standard deviation, right? This is the mean. So this is the mean, T. And this is the negative part and the positive part. So the upper limit and lower limit, have you seen it? This one. Okay. Then we have this mean here. We have this mean here. Okay. So what I'm saying is that this is standard deviation. The deviation is the distance between the mean and the unspecified requirement. In other words, take it to be the error. So if this is, you are a tailor and they have given you this measurement and your measurement that you brought is far away from this mean, then we say this is the standard deviation. Amma, do you get my point?
Yeah.
Okay, now this is the argument. So why are we having the standard deviation 6 like this? 3 here and then 3 here. And we are saying that each one is a sigma. So if you put the 3 on the left side and the 3 on the right side, that's lower limit and upper limit. It gives you what? 6. But why are we saying that the 6 sigma rather brings improvement when the sigma represents standard deviation? Do you get the question?
Look, isn't
No,
it
I want Amma. I'm coming. I want
okay.
Amma. I want to be on the same page with Amma. And she understands. I believe that you guys will also understand. Amma, do you get the point?
Yes, sir.
The deviation
So,
is so. Go ahead.
So like, I understand what you are saying. So the mean is more or less like the standard, the benchmark, and we are deviating from the benchmark. Yes.
Yes.
The requirements.
Yes.
So why are we saying that the deviation rather is reducing waste or is improving the system?
Fantastic.
Yes.
Yeah.
I get the question. I get the question. Okay, let me think about it again.
Yeah. So who else?
Doc, maybe let me try. Maybe if we know the standard, like the mean, and then we are deviating, I'm thinking that the lesser we deviate, or the lesser the variation progresses, the
Say that
better
again. The lesser we deviate.
Yeah, the better we can predict the outcome that we are expecting.
In other words, you are saying that for standard deviation, the figure, if it is small, you understand, you are not far away from the mean. You understand? The error of margin or margin of error is small. Agreed. That is a very valid statement. In fact, in standard deviation, if you have a too big standard deviation, then it means that that is going to create a big problem for you. It's possible that you have outliers in your data sets, right? Okay, so that's a valid statement. Now continue.
So I'm saying that so the lesser the more we can predict the outcome, and then we can make a practical statement and say this is what we have to improve about our quality.
Okay. Yeah, you are making a very, very valid point. I get your point. Yeah. Who else? I'm going to tell you something that probably this will be the first time you have heard. You understand? You know this bell shape, we use it to do so many things. Engineers, you remember the bell shape? You remember this? If you're an engineer and you've not done this, then it's a problem. Right? You remember? So, why is the place quiet like that? Charlie, I create a problem for you people, or you don't see these things.
No, it be rap attention. So we don't want to mix anything.
So what we are saying is that the idea of standard deviation, and let me tell you, life is about just two things. It's mean and standard deviation. Simple. And I give you an example. All the things that you see that have been manufactured, right? They use mean and standard deviation. So why do they use mean? So the sizes of shoes, they have 6, they have 7, they have 42, 43. But we have different, our leg sizes are different. Those who wear 42 do not actually wear 42 exactly, right? But there are variation of 42.1, 42.2, 42.3. They are always in the band. So the shoe size 42 is actually the mean plus a deviation that they have put in. So that even though we all wear 42, I know that when I measure my leg and yours, mine is a little bit longer than yours, but I'm still wearing 42. Okay. So shoes, even the chairs we sit on, we have the mean and the standard deviation. So what do? They take all our sizes, put it together, and have the mean. Then they strike the deviation. Now the deviation, so when they are producing the items, they will produce the mean, though, and produce these ones, okay, small ones, minus, or plus, up to what? 1. Okay, so they say that the shoe size is 42, but that is not the reality. It is 42 minus something and 40 minus. So there's a range that you have. And that range is what we are saying is the upper limit and the lower limit. The upper limit is the acceptable degree, you understand, of deviation that we can contain, okay, within the process, that customers will not say it is a defect. So when you see the 6 sigma, once we put the sigma there, the goal is that sigma means that between the mean and the standard deviation, we are going to improve the process and then put that sigma as part of what? So there will be a new mean which will be drawn. Okay, so what used to be a deviation now becomes part of the requirement. When we put another standard deviation, it also becomes a requirement. So 3.3, once we begin to introduce the standard deviation, which is the acceptable, allowable limit the customer will accept. Okay, take the deviation definition as that. Acceptable, allowable limits that the customer will accept. Once you put it there, then what it means is that you have removed that defect. So instead of the deviation being a stumbling block, it becomes a goal towards, as a goal for improvement. So the more sigma you have in your system, it means that the more you have expanded the requirement. And once you expand the requirement, because here, once we put the sigma here, it means that from here, they are all waste. So how do we bring them in? Once we introduce another sigma, then it means that we are getting to maybe 2 or 3 sigma. It means that we are reducing the waste. So the sigma now represents the allowable, tolerable limits that the customer will accept. In business, that's the meaning of the deviation. Does that make sense?
Doc, absolutely.
Yes, Doc.
Yes, Doc.
So if that is the case, now let's also go to a little bit of statistics. Now, you hear us talking about significance level, right? Have you heard about significance level?
Yes, Doc.
I know some people will say they know here before. Significance level, you have not heard it. What is a significance level in statistics? The term significance level. I'm saying this thing and it's going to help you with your research. What do you know about it? Hello?
Yeah, so in normal
distribution, I'm here. I like that. Who said that? In normal distribution, There's a normal distribution, yeah. Oh, someone they talk. Oh. In normal distribution, what? I'm just imagining looking at your face in class, the way your face they look like. Because I don't hear nothing.
Sorry. I had muted myself. So I was saying that your significant level is the level to which a significant test will reject your null hypothesis when it's true.
No. Joe, because you are taking us to statistics. Say it one by one, right? So let's go.
Okay, so I'm saying that it's the, so let's say you have a hypothesis, and then you conduct a number of tests. So the level, the significant level is the level to which the test you've conducted will reject the hypothesis you've claimed.
You've claimed, okay. Yeah. All right, so the significance level, okay, it's actually, the significance level is actually the level at which we reject the hypothesis. In other words, we have 3 significance levels in research that we use. We use generally. Now, when we say we have significance level, so for this thing, let me move to the next one. You realize that where we have the upper control limit and we have the lower control limit, this is symmetrical, so it goes, it doesn't touch. So when you come here, this one, makes it easier. Sorry. Oh. This one makes it easier. So you see this place, this small place. If you see it, just where this thing cuts off. So take this as the upper limit and lower limit. So this is the rejection, part, this part. Okay. So with the bell shape, we have 3 significance levels, either at 1%, at 5%, and at 10%. The social sciences uses 5 and 10. And then the physical sciences, like those doing hardcore sciences, okay, they do 1%. So the significance level is actually the margin of error that we see we can accept with the measurement. The margin of error. So that if your significance level is 1%, then you are only telling all of us that your confidence in the data is 99%. There's something called confidence level. It's the confidence you have in the data, right? So your margin of error is 1%. It means that you can trust your data by what? 99%. If the significance level is 5%, it means that you can trust your data 95%. If it is 10%, it means that you can trust your data what? 90%. So significance level is the allowable, tolerable limit or margin of error that the measurement can accommodate. So you are saying that with this study, by or large, I have 95% confidence in the data. The 95% truth in what I'm saying. And that is why in research, when you you generate your findings, you don't say that the study says that there is no relationship. No. The findings say that you say that it suggests, because knowing that you pick a sample from the population, you didn't pick everything. And then even with that, you gave yourself a margin of error of what? 5% or 10%, that there's the probability that you can what? Make an error. And it's the same thing we use in judging, the estimates that we do, all right? It's the same thing. The R-square and all this is the same thing. So just wanted to draw your attention to this. It's very, very important. So when you come here, the basic process limit you have here, you say this is the average, the mean. So between this one and this one, the sigma is here. So the 1 sigma, all right, the 1 sigma is either improving the process here or here, okay? And this is the improvement, that you do, 34.30%, okay? Then you go to 2 sigma, okay? What do you do? Between here and here is 13.60%. 2 sigma, here, 1 is knock off, okay? Then you go to 2, and then you get to what? 3 sigma. So you see that where the waste is lying, watch here, is 0.13%. The same thing here. You look at 6 sigma, it's 99.7 at 99.999999, and the last one is 7. You get it? The last one is 7. And let me go through so that you see. Okay, so here you have 68% of all data will be within what? Plus or minus what? One standard deviation. And that is it. And that is it. That is it. That's what he's saying here. All right. 1 between this range. That is 68.26%. Then 95.46% within 2 sigma. You see the 6 sigma at the 3-1. Okay. 99.74 in that order. Then only 2.4 parts per million will fall outside what? The 3 sigma. Only that is 2,600 parts per million will fall outside what? The plus or minus what? And that is actually this one. Okay, this one, this, and this. So this will be the defect. That's why we do 6 sigma. So the sigma level, the standard deviation, anytime it is introduced, what it means is that it's bringing rather an improvement. Those wastes are now be included in the requirement, okay? And customers are seeing that as part of the mean that they are measuring, okay? So they are moving the mean where it is, they are extending it to cover where they realized initially that was what? Waste. Are we good? So that's it.
Doc,
Yeah.
please can you go back to the bell shape?
Yeah.
I'm
This
a
one?
little bit, yes, I'm a little bit confused here.
Yeah.
No, where the figures are, yes. Okay, so if we are saying that the sigma is the deviation, that's the acceptable limit that a customer will accept.
Mm-hmm.
And then we are deviating from the mean, that's the average.
Now, with your definition now, all right, with your definition now, then when you say deviation, do you understand? It's not the deviation you are talking about. Now, when you say deviation is the acceptable limit. So let's go ahead.
I'm saying the sigma is like the, okay, I think I wrote something here. You mentioned something, you said acceptable, allowable limit a customer will accept. That's deviation.
Exactly. So keep that in mind whilst you are mentioning standard deviation so that you will not take the meaning as literally as we have. You may use it in this in making your point. Do you get what I'm saying?
Yes.
Yeah.
So when you get it that way, once you introduce the deviation, it's an improvement. It means customer is accepting.
Okay.
All right.
Yes.
So let's take it out from there.
Okay. So what my little confusion is with the first deviation, the first sigma.
Mm-hmm. If
we are saying that if we deviate from the mean, then means that we are far from what the customer, or we are far from the expectation.
No. You see, we have gotten there. Let's take the definition. Just read it to us.
So, the standard deviation is acceptable, allowable limits a customer will accept.
So when I introduce a standard deviation, it means that now it's part of the customer requirement.
Okay.
Agree?
Yeah.
Does that solve the confusion?
Yes.
So anytime I introduce any deviation, it means that there is an improvement that has happened. And let me take you here. So it makes life easy for all of us. So have you seen it? Yes.
Sir, so please can we say that the deviations are tolerances in the design, acceptable tolerances in the design?
No, fantastic. You have just brought, I was going to say that not now, but once you've brought it, it's fine. Okay. So the one, in fact, I mentioned is that tolerable limit. All right.
Okay.
Is the tolerance. The tolerance means that, watch here, 1 sigma 68.26%. All right. Defect per million opportunities is this. At 1 sigma. Do you get it? Now at 2 sigma, see the variation. When we introduce another, now the defect is what? 308.
Yeah, it's reducing.
It's reducing. So when we went to 3, it is what? 668. No, this one is wrong. Let me check. It's supposed to be 68,000, right? Okay, so 68,000. Oh, sorry. So this is 68,000. right? This is it. And then 4 sigma, 6,210. 5 sigma, 230. So that was what I want to draw your attention to. And anytime we introduce a sigma, there is what? An improvement. It means that what we saw as a deviation has been now included as part of the requirements that we are meeting for customers. Okay. So I just want you to, so that's the whole principle of the 6 sigma. Any sigma we introduce, any of the sigmas we introduce, it brings about what? Improvement. That's why when you do sigma 1, when you finish, you go and measure your system using your CPK to see the level. Then you move to sigma 2, you go and measure sigma 3. So it's all about measurement. Okay. About measurement. I don't know whether it makes sense.
Doc, it still doesn't make sense. Like I'm still not a little clear a little bit.
Go ahead. Yeah.
Okay. It's Eunice.
Oh, Eunice, yeah.
So,
no, so you were the one I was engaging. It was not Amma. Was it Amma or you?
I asked the question.
Say both of us.
But Amma, are you okay?
Yes, sir.
Okay, Eunice, let's go.
Yeah, so I was saying that, so if we are saying that the acceptable allowable limit a customer will accept, meaning that, like you said, meaning the customer has come to understand that standard deviation is part of the requirements.
No, it's not the customer that has accepted. We have given a requirement, okay? Average here. This is what the customer wanted, okay? So between this line and this line, we say it's what? A deviation.
Yes.
All right?
Yes.
Now, we have improved the system, okay? In other words, this line that is far, we have done improvement, and this line has moved, okay, to this, okay? That is 1 sigma. You get it? Yes. So what was the deviation has now been part of the requirement. That's what we are saying. And that's why we are saying that it is the acceptable, tolerable limit that the customer will accept. And let me use this. If you have the lower control limit here, it means that between this place is the lower limit the customer will accept. That is minus. And this one is the what? The highest limit what the customer will accept. This is plus. And that's why we say deviation is plus or minus. So a practical example. Okay, you go to the store to buy. What do you like? What do you like for Valentine? Let's use something. What would you like for Valentine? Say it to people are here.
That's a tough question.
It's a tough. You don't even know what you like.
I know. Yes, I don't know what I like.
I want to say a car. Okay.
No,
so let's
that's
say
unrealistic.
Unrealistic. At the haircut level, okay. So let's assume possible. It's what? Who said that? He said is what? Okay. So let's use that. I need an example.
A shoe.
A shoe. Okay.
That's possible.
Okay. So you need a shoe, right? And then what you said was that you want, what is your favorite color?
I'm a red girl.
Red. So red has variation. Red has variation. Who is that? Gideon, if you do that,
No, it'll be me, Doc. I mentioned shoe, but my reason for saying shoe was like I was trying to relate it to, when you want to buy shoe, they will tell you this is open, this is closed. But
even I don't want to go to the sizes. I want to use color, right?
Okay.
So you're a red girl. So you want deep red or light red, or there are variances.
Or blood red.
Christian red.
Christian red. I've never heard this thing even before.
That's
Christian
red. The blood red. Yeah.
The blood red. Christian red. then which other type do you like apart from the Christian?
Be a little bit
high heel or low heel.
Okay, high high hill or low hill. So, Eunice, that's what you said you wanted.
Yes.
Okay. So what you told Gideon to buy for the Valentine was that you want that Christian red. But you had also told him that if you don't get Christian red, okay, now once you introduce the if, we are moving to what? Standard deviation.
Deviation.
If you don't like the script, if you don't get it and you get light red, I will take it. So let's take that as what? The upper control limit. Now, if you also get deep red, I will also what? Accept it. Lower control limits. Let's say the negative. Now, so what the customer has said, so when I'm doing my requirement and we are producing the shoes, in our mind, we know that the customer says that she can take deep or she can take light. But the preferred one is what? The Christian what? Red. You get it?
Yes.
Are we okay? So that is how the standard deviation works.
Okay.
So once we are producing the shoes, in our mind, we know that should we get some of the, we are all working towards what? The Christian red, all right? But if we get some of them as deep and some of them as light, it is not an issue because the customer has given the lower limit and what? The upper limit, right? And then we can produce within it. Is that okay?
Yes. So a follow-up question. So if I'm saying that I want the Christian red, and then within the first deviation, you are able to give somewhere close to what I want. How is that less
Eunice.
Hello. Somebody hold the mic inside.
Okay,
Doc,
sir.
okay,
Since
Doc, let me
Eunice has
ask
gone
from
off,
here.
I want to say something. So in this case, does it mean that her preferred choice, which is the crimson red, becomes the mean? And
Exactly.
then the other shades of red become the like various standard deviation.
Exactly, plus or minus.
Yes, but say in this case, then which one is the upper limit and which one is the lower limit?
The upper limit will be the first, let's say the deep red, but the other one, the light red. We are using that just to describe, okay? The light.
Oh, okay.
Yeah, and then this one will be the deep one. So within this band, we can give the requirements. Yeah.
Doc.
Okay, so it means that the mean becomes like it becomes hair standard, and then the deviations become the other shades. And
No,
it's also
the deviation. The mean becomes hair preferred what standard.
Standard. Okay.
The deviation is the tolerable, allowable limit
that she would take.
Exactly.
Oh, okay. All right. So it means that if I also choose tomato red and then I get different other shades and I accept it, then that one become my preferred like tolerance that
limit.
I will accept.
So let me give you an example.
Right.
Amma, you are married, right?
No.
Okay, so let me give you an example. So you want a guy, okay? And then you say that, okay, for me, I want somebody who has masters, right? The person should be working. So when you said masters, it's okay. The guy should have master's degree. The guy should not be necessarily an engineer. You are starting. You are started with your standard deviation, right?
Yes, sir.
You understand? Okay. If he's, I want a tall guy, but anyway, I can manage with somebody who is medium. Standard deviation. Right? Okay. You send somebody to go and buy watch it for you. You said, okay, when you go buy Thalia, buy Gary, and then but if there is no Gary standard deviation, right? You are accepting something else, isn't it? So these things are in life. The things you do every day.
Sure.
That's what I'm saying. That life is all about mean and standard deviation.
Yes, sir. It makes sense. Yes. All right. Thank you.
All right, can we go ahead? I'm grateful that teaching this thing is not an easy thing. But if you people have understood, Nee, are you there?
Hello, sir.
Clifford, yeah.
Please, I want to.
Nee, Clifford, go ahead, yeah.
Yes, I want to be sure I'm understanding this right. So, with explanation given, does it mean that the higher the sigma, the lower the impact of the standard deviation on the absolute or true value?
No. Let's start your statement so that I'll modify. The higher what?
The higher the sigma. Maybe comparing one sigma.
No, the higher the sigma here means that the higher the introduction of the sigma within the process, isn't it? Not the higher the sigma as in the value of the standard deviation. You get what I'm saying? Because you could use that to explain something else. Because really, if standard deviation figure in statistics is big, you know what it means? It means that the deviation is big. That's what it means. You understand? But we are saying this within the context of process improvement. Okay. That when we introduce standard deviation in the process, the introduction means that there has been improvement. Do you get it? The sigma means that there has been improvement, which we have discussed now.
Yes.
Okay. So I just want us to get it from that perspective. So that because we use sigma in our daily conversation as a deviation. Okay. So how can a deviation become an improvement? And that's what we have explained.
Okay.
So in real life, in using your standard deviation, the smaller the deviation, the better, because it means you are closer to the mean. You understand? In real life, that's what it means. The lower the standard deviation, the better for you. Because if somebody deviates from this, okay, and he is somewhere here, boss, the person who is here is far from the right requirement, isn't it? That's what it means. But in system improvement, we say that once that you put the sigma in there, then it means that between here and here, do you understand? There have been some improvement for the customer now to accept this requirement as the mean. That's what we have discussed over this few minutes. And it is very difficult to get people to understand this variation. That's why we have to bring some of these things in for you to get it. So don't see, anytime you mention standard deviation in 6 Sigma, in your mind, you say that we are introducing improvement. Because see, if we move here, watch, and you can always use this table. At 1 sigma, there's the defect. 2 sigma, this is the defect. You get it, my brother?
Yes. So I think my my question actually is, so in the when you move from, say, maybe 4 sigma to 6 sigma, that reduces your DPMO.
Exactly.
In the process,
that is the defect per million opportunities. Yeah.
Yes. Okay. All right. That's
okay. Sir.
Yes.
Sir, so please, can you go back to the graph?
Yeah.
So, sir, please, per the explanation you just gave, Gideon, so it means that once the customer is accepting, it's not going to go waste. So it means it's improving the system.
Exactly. We move you into, so when you said that you want a tall guy, but you don't mind, a medium guy, no problem. You said you want the guy to have masters. I said that you can manage with what?
A medium person.
A degree, you understand? You can manage.
Yeah, a degree.
The guy should be, when he's rich, that is the preferred choice. That's upper limit.
Okay. Yeah.
But when he has not too much rich, you understand? But when he's okay, you accept. When he has a house, preferred. But if he's renting
Wait,
and
if
he
he's
has bought a
rented,
land,
yes.
he's
Yeah.
rented and he has bought a land, you will accept.
Yeah,
What have you done? And we do this every day, isn't it?
Okay, so you've accepted, like, yeah, you've reached an agreement, so you've accepted. But if you don't accept, that is where it becomes waste.
No, so if the customer says that limit is not acceptable, I mean, then it's not tolerable. I cannot tolerate somebody who doesn't have a degree. You understand? That is outside.
Yes.
All right. Aha.
Yes, sir.
So please, Eunice is here. Back. My question.
Yeah, Eunice.
Yes. So I wanted to ask that. What I wanted to ask was that.
Jackson, I'll be with you. Okay. Yeah. Go ahead.
How, if we are saying that the more we deviate from the mean, like the first deviation is the sigma 1, the second deviation is sigma 2, and that's the corrections that are being made until we get to the preferred what the customer wants. That's the 0.13. I'm saying that if a customer wants something, say I want the shoe example, and I want it in color, and then the manufacturer is able to give me at his first shot, okay, say between say sigma 1. How is then looking at the values you put up? How is that one, the margin of error, the defects per million? How is that one higher than the 6 Sigma? I don't get that analogy. If customers want something and we can provide it within our first attempt, then how is that one, like, how is the defects per million more than someone who tries it within 6 attempts?
No, but so that's a very good question. So we have started the improvement from 0. So to answer your question, we have started the improvement from 0. So as a company, you started measuring your Sigma level, right? Take notes. You started measuring your Sigma level. So from 0. So the first Sigma you are measuring is this one. And I can take you to what we did, the Dubai presentation, if you remember. There is, in fact, in the Dubai presentation, they have indicated, let me project that one as well. So please watch. You see at 1 Sigma, there's no improvement. Are you here? Eunice?
Yes, sir. Yes, sir.
At 1 Sigma, this is the defect per million. Okay?
Yeah.
Okay. So watch something.
Yeah.
At 1 Sigma, it means that, let's go back to, what it means is that, watch here. 1 Sigma, we are here. Okay. Upper limit, lower limit. Okay. So all these areas are defects because they are not within the customer requirement. Does that make sense now?
Yes, sir.
All these areas are defect. So when we go to 2 Sigma, we introduce this. Now, what was used to be a defect has now become part of what the requirement. Have you seen it?
But at 1 Sigma, you were able to give the customer what the customer wanted.
Now forget about what at 1 Sigma, okay, you were able to give this requirement. So this is how you explain it. To the extent that out of 1 million, let me go back, out of 1 million of the processes that you produce, okay, out of 1 million, you are able to satisfy, when you deduct this from 1 million, what do you get?
Let me do the math.
Okay. Mathematicians, where are you?
310,000.
You were able to satisfy 310,000 customers. That's what it means.
Yeah.
That's what it means. So explain it. Let's turn it that way. At 2 Sigma, because you see, at 1 Sigma, you have only satisfied that group of customers. Okay. These are defects that, fell off. And the same defect is what I'm showing you here. It's what I'm showing you here. This band and that band. These are all defects. So at 2 sigma, now this one has become part of the requirement. Okay, here has become part of the requirement. So don't look at the 1 sigma as that you have a band of customers. So within those customers, you have satisfied them. But we are saying that out of the 1 million, it is that's the 310 people that you customers that you've been able to satisfy. Fine. But the 690, they are all defects out of your process. That's the point we are making. So don't look at it from the fact that yeah.
If I get you right, like the shoe sizes example.
Yeah.
So if we produce a shoe size of 42, and then only 310 people who wear size 42 are able to get a perfect fit, then we are at 1 sigma. If you want everybody else that wear 42 to be able to get to be able to feel comfortable in the shoes, then we can go 2 sigma, 3 sigma, and the rest.
Exactly. And get them into, yes, and get them into the requirements. You get it? And get them in.
Yeah.
So that's what we are saying.
Okay, makes sense now.
Yeah.
Okay, thank you.
Once you understand, we are all fine. So, because of what we have done, let me just finish the DFSS and then bring you to this Nestle, project, so that we can. It's coming Ampon here. Okay, Ampon is not here. Okay, so we have discussed what 6 Sigma is in terms of project and all that, 6 Sigma benefits and all that. I don't want to get into this DMAIC. Okay, these are the phases. We have talked about this, the steps and the approaching. So what is DFSS? Okay, so we say unlike the dynamic methodology, the phase of the steps of DFSS are not universally recognized or defined. Take note, they are not universally, that's why we play it undertone that it works. Almost every company or training organization will define the DFSS differently. So many times a company will implement this strategies to suit their business, industry, and culture. And other times they will implement a version of DFSS to also to be by a consulting company and all that. Because of that, DFSS is more of an approach than a defined methodology. These are different things. It's more of an approach than a methodology that an organization uses. Okay, so one popular design for 6 Sigma methodology is called the DMAIC, all right, and retains the same number of letters, number of phases that we know, okay, as the DMAIC acronym. It retains the same. So the 5 phases of the DMAIC are the define, measure, analyze. Now you have design and verify. Design and verify. So define is the project goals, just as we have. Measure is to determine customer needs and specification, have the benchmark competitors. Analyze is the process option to meet the customer needs. And design is the detailed, the process to meet the customer needs. And verifying is the design performance and ability to meet. So that is what this is about. And I just want to take you to let me see, limitation and they are telling you the reason why they brought the DFSS. Okay, they are saying that the DMAIC approach can improve existing product and service to a level which are capable of, but the overall product or service performance may be limited by design. So the system is already there. You can improve it, but you cannot change the design. It's like changing a whole manufacturing setup. It's not possible. Okay, the machines, it's not possible. So we use 6 Sigma to do the improvement. And in order to overcome this limitation, DFSS approach is recommended as it covers a full range of product and service design, starting from the voice of what the customer and ending when the product was launched. So these are the impact of DFSS. I'm going to send the present. Tofik, did I send you the slides? If not, after this lecture, I'm going to send that to you. And
Okay,
these are
let me
the
quickly check on that.
advantages. The impact: shorter development cycles from idea to sale, reduction in design process complexity, reduce warranty costs after launch, reduce early life failures, increase initial customer satisfaction, greater efficiency in design resource utilization, less post-pilot design changes and all that. So this is how it looks like. This is the DFS. Yeah. Okay. That's how it looks like. So you have the resource level and the design level. You see the bell sheet. This is the budget resource utilization, typical DFS resource utilization. Then you have the actual resource utilization. Here, traditional post-release what problems, and this is the launch what dates. So that's how it looks like. It's not a complicated thing. So this is the design. This is the design, and this is just a matter of knowledge. Okay, just want you to know. And I'm saying this because I'm moving you to new product development cycle, and you guys will have to take this very serious. I do consultancy. What I'm going to teach is rather consultancy rather than the normal thing. So identify, design, optimize, validate. This is the IDVO methodology of the DFSS. There are different methodologies. So this one is identify, design, optimize, and then validate. And remember, we said that most of these, the DFSS do not have one strand of what methodology. We have different, people use different methodologies for this. I can tell you that if you come here, I saw something, okay. Okay, so we have the roadmap, okay, where the phases are here. When you look at the note, you see identify, just as we did the 6Sigma, what you have to do, still identification and then design. But this one is such that some of the processes stream into the other processes, okay? For instance, if you look at identify at this stage, there is this process that's stretched to through identify to what design. There's this apply noise what this one you see it stretches up to optimize, and then you have this one plan test for functional prototype verification, also between some part of design and then optimize, and it works that way. But when you put the whole process in stages, you're having about 8 phases or stages, and it's just amazing. You can use this if you want to really implement a new product. But for the new, these are all literature that we can read in terms of the cost savings for other organizations compared to the normal DMAIC model. I want to skip and then rather go to a new product development cycle, right? This one. That's what I want us to do, because this is and this one is you are using the DFSS, okay?